So now we're going to move on to more with quadratics, but now we're talking about inequalities. The first way we want to talk about quadratic inequalities is graphically. So we have a parabola, a positive parabola opens up, and a linear function that intersects it. And so the intersection points are AC and BD. So where is f of x, the green function, the parabola, less than g of x? Where are the y values from f of x lower than the y values from g of x? G of x is the linear function, the gray. Well, it looks like somewhere in here, yeah, these y values for g are lower than the y values for, these y values for f, the green function, are lower than the ones for the gray function. So this would be the interval a, b. Where is f of x greater than or equal to g of x? Now we're up here, right, in this area and this area. Maybe I'll make that dotted for. In these areas. So it'll be from negative infinity to a, and from b to infinity. Okay, so what we're looking at here is graphically where is the y values from the quadratic lower than the y values from the linear, and vice versa. Okay, so you're going to have to be able to do problems like that, but also algebraically, which is what we focus on a bit more. So when we're doing this algebraically, what we really need is to get 0 on one side of the inequality and everything else on the other. Factoring only works nicely if you have 0 on the other side, so that's what we have to do first. Then we can factor or use the quadratic formula on the non-zero side to figure out what would make that equal 0, because those are going to be the important pieces. Then we're going to set up a number line, and we're going to test values on each side of those two zeros, or maybe there's only one, but we're going to test values on each side to make sure we know, okay, what's happening with the quadratic in each of these places. The other way to do that, instead of making a number line, is to say, okay, does this quadratic open up, and therefore it's lower on the bottom than it is, like lower in between them? Or is it open down, and so it's higher in between? And then you write out your solution. So let's do that. Here's our first example. We have x squared plus 3x is greater than 10. So first step first, we have to move the 10 over. And then we need to factor. And in general, these will factor. Not always, but commonly these will factor. So my zeros are x equals -5 and +2. Okay, so now here's where our options come in. I tend to default to making a number line because this is going to be useful later when we have higher degree polynomials that are talking about inequalities. But right now, we just have the two, -5 and 2. So you have options. I usually set this up with my factors. I have x plus 5, x minus 2, and then f. And I'm going to test values on each side. So -6 is between these, 0 is less than -5, 0 is between them, and 3 is bigger. So we can sub those in. Let's see, if I put -6 in here, I get a negative. If I put 0 in, I get a positive. And if I put 3 in, I get a positive. If I put -6 into x minus 2, I get a negative. 0 in, I get a negative. Put 3 in, and I get a positive. So now I know what the signs of each of my factors are doing. I'm just multiplying them together, right? So a negative times a negative, that's a positive. A negative times a positive, that's a negative. And a positive times a positive, that's a positive. So now I know what my function is doing. It's positive, less than -5 and greater than 2. It's negative between -5 and 2. And it's at 0 at -5 and at 2. So I could have done this by skipping this part. That's not necessary, right? We don't have to do the middle. We could have literally plugged in -6 to the function itself, 0 to the function, and 3 to the function. Or we could have said x squared plus 3x minus 10. This opens up because the x squared term is positive. Zeros are -5 and 2. So we want greater than 0 means outside the zeros. Our x's, we want positives. They're going to go here and here. So anything less than -5 and anything greater than 2. So our solution set is -infinity, -5, and 2 to infinity. Notice I'm using parentheses everywhere because I'm not allowed to be equals to here, and I can never equal infinity. Okay, so you have 3 different ways we can do this. You have to get everything on one side, right? That's the one piece we have to do. After that, you can factor and put those into this little table and make this table every time. Or you can find the zeros from the original and then say, okay, let's figure out what's happening in between and outside those zeros. Or you can find the zeros and then use the shape of the parabola, opens up or opens down, and knowing what that means. However you do it, you need to get this answer. All right, let's do another one. 25x squared plus 16 is less than 40x. So now we're getting into some bigger numbers. Get everything together. Now we want negatives, so we need to find our zeros. This does factor. Not sure I can do it off the top of my head. I think this is a perfect square. 25x squared minus 20 minus 20 being minus 40 plus 16. Okay, so it factors like that. So I only have 1 0. Four-fifths. Now I only have 1 0. What does that mean? It means if I was graphing this, my vertex would be on the axis. So I don't ever go below the axis. And this opens up. So if the vertex is on the axis and it opens up, and I want less than 0, I get that that never happens. I can also do this with the line. 4/5 goes here. I get that f of x is positive here and positive here. So again, it's never true. And that's always a possibility. We could have had no intercepts, and that would have been a thing. And then we would have just said, okay, is the whole thing positive or is the whole thing negative? Because that'll tell us that too. All right, now your turn. Here's your function. Pause it here, take a minute, and do this one yourself. I can promise you it does have zeros, okay? So you will be able to, and I think it does factor. I don't remember. It might factor. So you can try that. No promises. But try that out. See if you can get these solution sets yourself. How did it go? Not bad? I moved everything over. 6x squared minus 5x minus 6. We want that to be less than 0. All of these wanted less than 0. That's not fun. I was able to factor. And I got my 2 zeros, -2/3 and 3/2. So they're not pretty zeros, but they're there. And then I completed the table and got between them, right? I want to be lower, so I'm going to be between them. But I also could have said, okay, it opens up. We want less than 0, so since it opens up, that's going to be between the roots, and so that my solution set is that, -2/3 to 3/2. Either way is up to you. All right. That's not the only thing we have to do in here, though. We still get word problems. All right. Suppose John Deere has found that revenue from sales of its heavy-duty tractors is a function of price, given by this R of P function, this revenue function. Revenue equals -1/2 P squared plus 1900 P. At what prices P is revenue $0. So what prices can we charge and sell nothing or make nothing? So that's where we just want equal 0. So 0. So 0 equals -1/2 P squared plus 1900 P. Since 0 is already over there, I'm just going to factor the other side. And I should get P times -1/2 P plus 1900. So then P equals 0, or -1/2 P plus 1900 equals 0. That's going to mean -1/2 P equals -1900. P equals 3800. Okay, so our two amounts that we can charge is $3,800 and $0. If we charge $0, we're going to sell loads of them, right? But we're not going to make a dime. If we charge $3,800, we'll still sell 0 because nobody will want them. So now we know what range of prices to be between, but now we want to know for what range of prices will revenue exceed $1.2 million. That's a lot of money. Let's see how we can do that. Well, we want revenue, so -1/2 P squared plus 1900 P to be greater than exceed $1.2 million. Okay. This is a quadratic. This is what this whole section is about, right? We just threw some words in there. Now that we've translated it back, we're just going to move everything over, get 0 on one side, and find the zeros. 1/2 P squared plus 1900 P minus $1.2 million needs to be greater than 0. Okay. Now you have some options. I did this one out by getting rid of the number in front of the P squared, but if at this point you would rather use the quadratic formula, do that. Get your values, and then use those. I'm going to do this out the way I said I was going to do with, I like to factor. Let's try that way. So if we multiply everything by -2, right, to get rid of that -1/2, I get P squared minus 3,800 P plus 2.4 million is now less than 0, right? I swap my sign because I multiplied by a negative. And then 3,800 both add up to 3,800 and multiply to 2.4 million. So my x's are $3,000 and $800. Now that we want to be less than 0 and it opens up, we want to be between them. So the range, sorry about that. The range of prices is $800 to $3,000. Hopefully you got the same values from your quadratic formula. All right, so that was another short one. I'm kind of skimming through this a little bit fast because it's a video and I can't interact with you, and so I can't explain this as well, like, without having you right here to ask those questions. So ask those questions in class. Send them to me in a message somehow, text, email, whatever. Canvas, there's lots of different ways to send me messages. Ask those questions now, because if you're confused, I want to help. I just don't know how or where you are confused. So let's have that conversation, either with your classmates in class, with your classmates outside of class, a tutor, myself. Let's get your help, because if you feel at all confused about what we just did, we definitely want. I definitely want to see you get help understanding it. So my advice for this is to be careful with your factoring, right? Make sure that you're checking those values that they actually work. Remember that the quadratic formula always works. You can use that to factor it for you. Or you can always use the quadratic formula and then go back to the original or use its shape to test. And so there's lots of different ways to do this. Don't feel tied to having to factor if you don't like factoring. And then make sure your number line is set up as a true number line. You want to choose your testing points carefully. As we move on, when we get into later sections where we actually start dealing with polynomials, so like higher degree inequalities, we're going to have lots of things to keep track of, and there's a definite chance that you will forget that 0 is not between 1 and 2. So make sure that you're checking that you're testing your number line properly. With quadratics, you should never have two of the same signs in a row unless there's only 1 0. That was the only time we would see that. So it should definitely change signs each time. So make sure that it's doing that like you were expecting.